So we've learned a number of concepts dealing with analytic geometry, and now we're at a point where we're going to use these tools to help verify geometric properties. So today our goal is to use all the formulas we have learned to verify properties of geometric figures. So to verify geometric properties, we use one of our special formulas or equations, and it helps to answer questions like, so here are some examples. So you may get a question like, show that the quadrilateral with these endpoints is a trapezoid. Or verify that the point 3,5 is on the perpendicular bisector of a line. Or show that the diagonals of a square bisect each other. So it's important when we're doing these questions, you know, you need to know the meanings of these. Okay, so we're going to spend a couple of days practicing these types of questions. So we will, you know, we'll have an opportunity to review some of these. I would imagine that some of these things you do know what they mean, and others you may not be clear. But you know, in each question, you need a plan of attack, and sometimes you have to kind of work backwards in your thinking to come up with that plan. So in example 1 here, it's find the equation of the perpendicular bisector of a line segment with those endpoints. Okay? So I'm going to just draw a picture of what this looks like. Now the picture is not necessary, but I really feel like in this question it's going to be helpful to get a sense of what the picture looks like. So I've got my y and my x. So one of my endpoints is at 5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And remember, this doesn't have to be a perfect picture. We just want to get a picture of what it kind of looks like here. The other endpoint is -7, 8. So 1, 2, 3, 4, 5, 6, 7. And then up 1, 2, 3, 4, 5, 6, 7, 8. So I've got a point up here. So this is the point 5, -4. And this is the point -7, 8. All right, so I'm going to draw that line segment. And so the first thing we need to talk about is, what does that mean? Well, we know what perpendicular means. We know that that's a line that is perpendicular to this line here. But what does bisector mean? So bisector, if you bisect something, you cut it in half. So if you think about dissecting in science, if you're dissecting a bug or something, a frog, when you dissect it, you cut it up. When you bisect it, it means you cut it into, you don't cut it in half, you cut it in half. I don't think there's any danger of me teaching English. I think they'll probably keep me in math. But when you bisect something, you cut it in half. So what we're looking for here then is a line that cuts this line in half and it crosses it at a 90-degree angle. Now, I'm not certain that that is the perfect perpendicular bisector here, but I'm just going to label it so we know what we're talking about. So that is the perpendicular bisector. And if it is in fact a perpendicular bisector, that's a right angle there, and this side of the line is equal to that side of the line because the perpendicular bisector cuts it right in half. All right. So if we're trying to find the equation of the perpendicular bisector, we need slope and point to find equation of the perpendicular bisector. Okay, so really I haven't done anything yet, but I've kind of come up with a little bit of a plan here. Because if I anytime I'm trying to find the equation on a line, I at least need to know 2 points on the line, or a slope and a point on that line. So ultimately I need to find the slope of the perpendicular bisector and the slope of the point. Or sorry, and the point that, that is on that line. Okay? So, what do we know about the slope? Well, we know that the slope of the perpendicular bisector is the negative reciprocal of the other line. So I'm actually going to call this line AB, so we know which line we're talking about. But this is an important thing for us to realize in order to help find the equation of the perpendicular bisector. So we know that the slope of this line is going to be the negative reciprocal to the slope of that line. Okay? The other thing that we know is that if we're trying to come up with a point that is on the perpendicular bisector, the midpoint of AB is on the perpendicular bisector. So those are the two pieces of information that I need to come up with. So let's start with the slope. So for the slope, so over here I'm working on finding the slope. So the slope of AB I'm going to find first. Okay? So remember to find the slope. I subtract the y's on the top, and I subtract the x's on the bottom. That's our formula for slope. So in our case here, I'm going to start with the 8, so I'll do 8, and if it's 8, subtract negative 4, that's going to be 8 plus 4, and then I'll have to start with the negative 7, so negative 7 minus 5. So what I end up with there for the slope of AB is 12 over negative 12, and that's equal to negative 1. So that's the slope of AB is negative 1. So the perpendicular slope, which is the one we need, we have to flip it over and change it to positive. So if you flip negative 1 over and change it to positive, you're going to end up with 1. So we've got the slope of the line, or the slope of the line that we need for the perpendicular bisector. Now we need to work on the point. So the point is the midpoint of AB. So I'm going to write down my formula for midpoint. And one thing to remember is that, just like we did with trigonometry, when we get to the test on this stuff, you are going to be given all these formulas. You don't have to memorize them, but you do need to know when and how to use them. So now I add the x's together. So the x's are negative 7 and 5. And the y's are 8 and negative 4. So my midpoint here is negative 1, 2. So now I've got a point and I've got a slope. So I'm just going to try and fit that into here. So I'm going to use my perpendicular slope, which is equal to 1, and negative 1, 2. There's no fraction slope here, so I can use y equals mx plus b. So my y is 2, my m is 1, my x is negative 1. And when I move things around here, I end up with b equals 3. So therefore, the equation of the perpendicular bisector is y equals, and we already know that the slope is 1, x, and we just found the y-intercept. So that is the equation of the perpendicular bisector. Okay? Lots of great work in a question like that where we're using a lot of the different formulas that we've used before. So I really do like those questions, even though you guys may not, because there is a lot of work to do. Example 2, I'm going to leave that. We'll do some of that in the warm-up tomorrow, and then maybe some of that in the warm-up on day 2 of our working practice periods on this stuff. Okay? So we'll see you tomorrow. Thanks.